Alright, for today, we'll be talking about hyperbolas, the third type of conics in our unit. So I know it says number 9 for our entry, but I know yours will be a little bit different. This is just what it happened to be when I recorded this. Now I notice if you look at it, oops, I gotta erase that. That shouldn't be there. Okay, now if you look at it, you have these two equations. You see two sets of fractions. You see two of them equal to 1. The main difference you should see between this and an ellipse is that you have that special minus sign in between. That minus sign is going to be your clue that we are talking about a hyperbola here and not an ellipse. So I'm going to go through now and cue up our little video. Okay, so you look, here we are emphasizing the minus signs here, really drawing your attention to it. That's going to be your main clue that we are talking about hyperbolas. And now, every time we do an entry, we go through and we talk about our standard. The standard we are doing with today's lesson is we're talking about MM3G2BC, which is essentially talking about graphing using the standard form of the equation for hyperbolas. So, first thing you need to know is that where these little lines intersect here inside that little gray box, that's going to be our center. Just like circles have a center and ellipses have a center, hyperbolas have a center as well. And we use this when we're counting it out to try and draw our hyperbola. Just like we do with ellipses, our A's are going to count to the left and to the right, and then our B's are going to count up and down. So that's how we go through and make the box. A's go left and right, B's go up and down, and we go through and make this pretty little gray box. Once we have that gray box, you notice we draw these little lines through the corners. Those lines right there are going to be our asymptotes. Now, if you recall back from when we did exponentials and logarithms, those asymptotes are lines we never ever cross, we never ever touch. It's like driving along a brick wall. You don't want to touch it, you don't want to crash into it. So we're going to use those to help us draw our hyperbolas, which are going to be a set of curves. So let's go through, let me erase my asymptotes word. Well, I'm having to talk after something I've already recorded. So let's see what happens. Okay. As you can see here, I circled that X in the front. That's going to tell us particularly which way our hyperbola is going to open. Now, if you think the x-axis goes this way horizontally, so it's going to make sense that we're going to open up to the left and to the right. And so as you see, I've drawn my little curve along the asymptote, touched the black box, touched the gray box right there at the point, and came back along. I did the same thing on the other side. Started at the asymptote, touched the box, and came back off again. Now those 2 points right there, those are important. Those are going to be your vertices. Those are going to be very important. You will be quizzed / tested over this, so make certain you know what those are and you can be able to give me coordinates of those. And of course, since X is going to go left and right, this one has a Y in the front, so it's got to do the opposite. It's got to go up and down. So start off next to our asymptote, we touch our little gray box right in the middle, and we come back up again. And we're going to do it again on the bottom. Come up, start up next to the asymptote, come up, touch the box right there in the middle, and come back down again. Once we have that, we're going to do the same thing, and we're going to color in where our vertices are. That way it makes it a little bit easier for us to see. I know you guys tend to make fun of my use of color, but I have to have it. It makes it a lot easier for me to see. All right, now that we have our vertices, if you look, we've got these little purple dots here on the ends. The main thing we haven't talked about yet are our foci. Now, these are going to be our foci. I know you would normally think it's supposed to be inside the shape, inside the ellipse, inside the box. But if you think hyperbolas are kind of like the opposite of ellipses, so instead of being inside the box, it's going to be outside. And if you look, it's going to be on the same sides as your curves. So there's a foci here, foci over there, foci up here, and a foci down there. All right, let me check and make sure our recording is stopped. So we're going to go on to the next set, and we're going to talk about standard form for a second. Now, these two equations that you see here are essentially the same thing, but it just tells you which way our open. But this is also the standard form that we need. If we do not have it this way, we cannot graph it. So let me go through, and I'm going to start up our recording. This is the main thing you need. And give me a second here. This is the, oh. Okay, let me fix that. Give me a second. Where this is the form we have to have in order to graph it. If we don't, we're going to have to do that completing the square that we learned and go through and change it into this. Okay, so. All right, next thing on our list is our center. It's one of the first things we have to find every time. And if you look, they each have an H and a K. H is always with X, K is always with Y. So this one's also going to be H comma K, just like we did with circles and with ellipses. We're going to take the opposite of what's there. If there's no number with it, we're going to put a 0. Make our life a little bit easier. Now our opening, we've already talked about that a little bit on the other slide. If it's got an X in the front, it's going to open to the left and to the right. If it's got a Y in the front, it's going to open up and down. The X in the front kind of makes me think of a tornado, if you look at it, or if you can think of an hourglass shape. The Y, sometimes you can see like a rainbow, sometimes it's kind of like a frowny face. Now our A and B, those we're going to find the exact same way we did for ellipses. A is always going to be the square root of the number underneath X. So sometimes it's a whole number, sometimes it's a decimal. It just depends on what you get. And just like before, A is going to let you count left and right from your center. Now on the next video, we'll be going through and especially how to graph from the ellipses. So this will be where it becomes important there. And for B, it's going to be the square root of whatever number is underneath our Y. It doesn't matter if it's in the bottom part of the equation or out in there in the front. And we're going to count up and down. Now our foci is where it's going to get a little bit weird. Now our foci, with ellipses, we would subtract them, big minus small. We're actually going to add them together. Add the two denominators together and then square root it. Because if you think, it goes out past the gray box. We don't want it to be smaller, we want it to be bigger. So we're going to put that plus sign. Another way some people remember it is that they think the plus sign there is the opposite of the sign that's in the original equation. So with ellipses, it had a plus sign there with a minus sign for the foci. With hyperbolas, it had a minus to start off with, so it's a plus sign right there. It helps some people out a lot. So we're going to move on to our next slide. Practice problems. Now, there are 4 problems here. I would like for you to take a minute, go through and try each one. Pause this if you need to in order to do that. Determine the center, how it opens, its value for A, for B, and for its foci for each one. Some of them are kind of tricky, especially number 4. Don't let it get you. All right, at this time, we're going to start going through the answers here. So I'm going to play my recording, and let's watch what happens. All right, as you can see, we got to pull out the center, which is going to be your opposite, so 2, -4. For your opening, you got to think X is in the front, so it's got to open left and right. Now, A is always the square root of what's under X. So 36 is under the X. Square root of 36 should be one that you automatically know, should be 6. B is always the square root of what's under Y. So it's a 9, so square root of 9 should be one that you automatically know, should be a 3. Now for your foci, you need to add those two together. 36 plus 9 should end up giving you a 45. And if you think 45 is kind of halfway in between 36 and 49, probably a little bit more than that. So you could probably give a rough estimate of about 6.6, 6.7. As long as you're somewhere around there, if we want to be accurate, we could bust out a calculator and do it that way. All right, moving on to number 2. For our center, it's going to be our opposite, which is going to be our -4 and 3. Make certain you did it that way. If you did it as 3, -4, you forgot to look for what was in the front. There was a Y there, which is going to tell you it's going to open up and down, but make sure you get that center right. Now for your A, make certain you pick the one that's under the X. It's trying to confuse you. Don't let it do that. So for your B, square root of 25 should be an automatic 5. Should be one of those you automatically know off the top of your head. Our foci, since we are talking ellipses, we are going to add them together. So 25 plus 9 should give us 34. 34 is a little bit less than 36, which is 6. You could be safe and say anywhere from about 5.8 to 5.9. If we want to be really accurate, we'd break out a calculator. But as long as we're pretty close, we'll be okay. All right, next one. Number 3. Number 3, we've got X in the front and again, so it's going to make it a lot easier for us. So just pull out your opposites. So 5, -2 will be your center. And we already mentioned X is in the front, so we know it's going to open to the left and to the right. A is always the square root of what's under X. The square root of 9 is going to give you the 3. And then for your B, square root of your 4 is going to give you that magic 2. Then for your foci, because we are talking hyperbolas, add those denominators together and get 13, which is a little bit less than 16, about halfway. So you could probably say about 3.5, 3.6, somewhere around there. Then last one, number 4, kind of tricky. It does have that y in the front, so don't let it get you. So we had to start off with the 4. There's no number with the y, so make certain you put that 0 with it. Y is first, so it is going to open from up and down. A is always the square root of what's under x. The square root of 49 should be 7. B is always going to be your square root of what's underneath y. So the square root of 81 should give you 9. And then for our last foci for number 4, add together your two denominators. And if you think 81 plus 49, that's going to be kind of a big number. So if you need to break out your calculator for a second, should give you 130, which is a little bit less than halfway between square root of 11 and 12. So you could be safe anywhere from about 11.4 to 11.5. And that pretty much ends us for today's on finding those several things about hyperbolas. The next video we will do will be particularly dealing with graphing hyperbolas and going backwards and forwards.